Hi. In the last video, we looked at global route selection policy based on the bandwidth of different links. In this video, we are going to first look at the load balancing by using or by considering link quality. By link quality, we mean that the firewall is going to send probe packets to the different links that are available, and based on the amount of packet loss or delay or jitter parameters which the firewall is going to measure from those probe packets, it is going to determine the quality of each link. So for example, if we consider the packet loss ratio, which is the most important parameter to consider as compared to delay and jitter, and in most of the cases we consider packet loss ratio for deciding the quality of each link. So if we can see that in this scenario, the link going through ISP1 has got a packet loss ratio of 0% or 0 out of 5 packets were lost, which means this is a good quality link, as compared to these two links which have got either 2 out of 5 packet loss ratio or 5 out of 5 packet loss ratio, which is the worst case scenario. So we can see that this is the healthiest link, this is the second healthiest link, and this is the third healthiest link, or rather the unhealthiest link, most unhealthiest link. So in this scenario, what is going to happen is that most of the traffic is going to be sent through ISP1, because ISP1 has got the link with the best quality, and the traffic is going to be sent through ISP1. So therefore the firewall determines that ISP1 link has the highest quality and preferentially uses ISP link 1 to forward traffic unless the probe entry is aged out. So as long as the probe entry shows that there is no packet drop, there is no packet loss on this link, the traffic is going to be sent through this link. If you look at the configuration, once again you edit the global route selection policy, and this time instead of selecting load balancing based on link bandwidth, we select load balancing based on link quality, and then we select the parameter to be used for checking the quality of the link. And as I mentioned earlier, generally the packet loss ratio is selected. So we select packet loss ratio, and then we include the links which we want to use for load balancing with traffic across. The next method that we use is the load balancing by link weight. This is another global route selection policy mechanism in which we assign different weights to different links, and then we forward traffic based on those weights. If you look at this example, once again there are 3 links going through 3 different ISPs, and each of those links has been assigned certain weight. For example, ISP1's link has been assigned a weight of 5, the ISP2 link has been assigned a weight of 3, and the ISP3 link has been assigned a weight of 2. These weights are assigned on some parameter, for example the cost of these links. So if a link is cheaper, we might assign it higher weight, which means that this is more desirable, and a link with higher cost is assigned a lower weight. So this is something which we can decide arbitrarily, and we can assign any weight to each of these links. So here we've assigned weights of 5, 3 and 2 to ISP links 1, 2 and 3, and based on these weights, when sufficient amount of traffic has been passed through these links, the traffic distribution or the percentage of traffic across these links is going to be 50% through link 1, 30% through link 2 and 20% through link 3, based on the weights that we have assigned to these interfaces or to these particular links. And once again, the overload protection threshold is going to come into play, and it is going to make sure that if the load on a particular link reaches 90% of its overload protection threshold, then no more traffic is going to be passed through this particular link, and the other links are going to be used. So any of the links, if it crosses its overload protection threshold, it is not going to carry any more traffic, and the other links are going to be used for forwarding the remaining traffic or the traffic that's coming next. If you look at the configuration is once again very similar. We select the mode as load balancing based on link weights, and then we include the links which we want to use for forwarding the traffic based on their link weights. The final global route selection mechanism is based on link priority. This is used for not for load balancing but for active standby deployment or active standby implementation of traffic forwarding through different links. In this case, we see that we have assigned different priorities, for example priority 8, 6 and 2 to ISPs 1, 2 and 3, or the links to ISPs 1, 2 and 3. In this case, the link with the highest priority, which in this case is link 1, is going to be used for forwarding all the traffic towards the internet. Links 2 and 3 will not be used unless the overload protection threshold of the first link or the highest priority link is exceeded. So whenever the traffic through ISP 1 goes beyond the overload protection threshold, only then ISP 2 and ISP 3 links would be used. Next will be ISP 2 link, and once the capacity or the overload protection threshold on ISP 2 link exceeds 90%, then we will start using the ISP 3 link. So in this case, it's not a load balancing mechanism, it's an active standby mechanism whereby only one link is being used at any given time. Its configuration once again is fairly simple and similar to how we did the configuration earlier. You select the selection mode as active standby, backup based on link priorities, and then we select the links and they are going to be preferred based on the priorities of these links. And there is another concept here which we have been seeing in the previous slides as well, however we did not discuss that, but now is the time to discuss this concept, that is of sticky session. Sticky session right now you see is disabled here. Sticky session or enabling sticky session is a very useful feature. However, in order to understand sticky session, let's first understand the concept of overload protection and how overload protection can cause problem in certain situations. Look at this scenario where we have two user groups, user group 1 going through ISP 1 through gigabit interface gigabit Ethernet 1/0/1, and the user group 2 is going through ISP 2 using interface gigabit 1/0/2. In this situation, if you see that, let's suppose the link for ISP 2 exceeds the overload protection threshold, then the traffic from user group 2 is going to be forwarded through the ISP 1 link and not through the ISP 2 link, because this link has already crossed its threshold. The next traffic coming from user group 2 is also going to be forwarded through ISP link 1. However, the problem that we are going to face is that when we forward the user traffic through ISP 1, the application traffic of an established session is going to be disrupted, or it's going to be interrupted, and the session will have to be established once again. So the users are going to experience service interruption, which will result in bad user experience because their link has been shifted. So they are going to experience service interruption, which is not a desirable effect. In order to avoid this, we can use the feature of sticky session. In case of sticky session, if we enable the sticky session feature on the firewall, what will happen is that if the overload protection threshold is exceeded on this particular link, the traffic for user group 2 is going to be shifted through ISP 1. However, the existing sessions or the existing connections that are established, the traffic for those existing sessions is not going to be forwarded through this link. That traffic is going to be continuously be forwarded through the same link so that the users do not experience any service interruption. The new traffic that is going to come from this link, only the new traffic is going to be forwarded through ISP 1 so that new sessions can be established or can be created through the ISP 1 network. In this way, the users will not experience any service interruption. So this is the feature of sticky session, which if required can be enabled on the firewall using global route selection policy. So this is how we implement global route selection policy using sticky sessions. If you want to look at the existing sticky session entries, you can issue the command display session persistence table and you can see that there are two sticky session entries, or there are two sticky entries in our session table which are going to be persistent, which means that these two sessions are always going to be using the respective interfaces that are given in the persistent session table. So this was all about global route selection policy, overload protection threshold, and sticky sessions. In the next video, we are going to look at certain other features for intelligent uplink selection, like policy-based routing. So see you in the next video.